this project, which is XOR. Now, XOR, we talked about before, it works bit on one bit at a time. So if you have two pieces of data and the two bits are the same, the answer is 0. If the two bits are different, the answer is 1. That's it. That's XOR, exclusive OR. It means one or the other of these is 1, but not both. And so, to XOR characters, you encode the characters in ASCII. So A is this, B is that, and C is that. And so if you want to do A XOR B, you'd write them here. And so these bits are the same, you get 0. These bits are the same, and you get 0. Same thing holds to here. These last two bits are different, so you get 1, 1. So A XOR B is the binary 3, and that is not a printable character. If you take a look at the ASCII table, 3 is something called end of text, some unprintable character. Most of the printable characters start at 32 and above. That's where you find things like space and punctuation mark and letters and numbers. The ones below 32 are pretty much strange unprintable characters. All right, so that's what happened. A XOR S is printable though. And A, if you go here, and capital A is 65, which is 41 in hex, and you can therefore do 41 here. The left nibble is 4, 1, 2, 4. The right nibble is 1. Remember, the way to do this in hex is to do 4 bits at a time. This is a 1, and that's a 4 on the left. So this is 41 hex. Now an S, a lowercase s, is here. It is 73 in hex. So again, you can read it right off here. The left nibble is 7. That's 1, 1, 1, 1 plus 2 plus 4. And the right nibble is 3, 1 plus 2. So this is S. And now if you XOR them, these bits are the same, and those bits are the same, but these two, the bits are different. So you get 1, 1. The next two match. This one's different, and that's the same. So you get this. 1, 1, 0, 0, 1, 0. So that is a 30. That left nibble is 3, and the right nibble is 2. That's 32 in hex. And if you find 32 in hex, that is a 2, a decimal 2. So that leads you to the strange situation. A XOR S is 2. And that's why people use it for encryption. It's very fast and easy for the processor to perform, and it scrambles the letters pretty well. Now, it's not very secure to XOR with just 1 byte because there's only 256 possible values, and you can just try them all. But it is used as part of really serious encryption algorithms like AES. So here's the assembly code to do XOR encryption with a single key. And that's I'm calling, let's see what I have here. I should have it here. XOR 1 .asm. All right, so you see here, I define the start here. So the first thing I do is move in ECX, the length number of characters to encrypt. And then I just push that. Here I make a loop. I push ECX, and then for each character, I'm going to move. Now what I did not read data from the user. I just put data here. So I define a message, which is hello, carriage return line feed, and that's just the end of it. I'm just going to work right here. So you put your message right there in the source code, and it's just going to encrypt this with a key, and the key is going to be a fixed 3 here. So I'm just going to XOR it all with 3, and all that's going to do is flip the last 2 bits. So it's just going to move the letters forward or backward by just some number between 1 and 3. So it's not going to take the printable characters and make them unprintable, which is what I want to avoid. So this is going to, so I prepare by putting ECX5. Now you may remember the loop instruction if you've been doing the tutorials on assembler. Loops back to here, and it will keep looping until ECX is 0. The ECX register is special for that purpose. So that's a handy way to make a loop in assembler. So I define the loop here. I push ECX because I'm going to have to use it. I thought I would have to use it here. Looks like I didn't, but anyway, just out of habit, I pushed it so I would preserve it, and then popped it here. And so here, I move the start of the message here. I add ECX to it. So I move that deeply into the message, that many bytes in. Then I subtract 1 from EBX, and then now why did I subtract 1? I'm trying to remember why I subtracted 1. EBX is going to be the start of the message. Oh, that's just record where I am. Now I'm going to be address of current character. Oh, I remember, because ECX starts at 5 and I have 5 letters. So I'm starting counting at 1 instead of counting at 0. So instead of moving forward 5 from the start, which would take me off the end, I subtract 1. I probably could have just put a 4 here. Anyway, that's why this is here. So now I'm at the byte I want to process. So I move into the 8-bit A register, the value of the current byte I'm trying to process. That's this address, EBX. Then I XOR it with 3, and then I put it back, move it in there. This is what does the job. This takes the current character, XORs it, and puts it back. Now I just pop ECX to restore it from where I saved it, which is not really necessary since I didn't use it here, but I got in the habit of doing that because I hadn't written this part yet, and I thought I might want to use the C register, and if I do, I don't want to lose its value. And then I loop, and the loop will loop here, and there should be, I think the loop automatically decrements ECX every time and stops when it hits 0, so I don't have to write that part. So this will go backwards, starting at the last character down to the first character of this hello. And then when it's done, I just print it out. And this is the standard print message we've seen in the Hello World program and everything. You just feed in the length, the message, device 1, which is standard output, and system call number 4, which is write. So this will just print that message, and that's it. And here is exit. It's just call number 1. So that's what's going on here. And so if you run this one, which is XOR 1, then you get the encrypted message, or each thing is XORed with 3, so it moves each letter by a few letters in the alphabet. The H turns into a K, the E turns into an F, and so on. So that's a simple XOR program. And so you have a couple challenges here. Here you just have to XOR this with a key of 11, so a small modification of the previous program will do this. You just need to change the key and change the data and change the length of the data. And here you got one without knowing the key, but I tell you the key is between 1 and 40. So you're going to have to make a loop that tries all 40 of those keys and just print out all 40 of the answers, and one of them will be readable and the rest will all be garbage. So that's XOR. Let me stop this one.